So we have this interface, math processing, that models the concept of a class being able to identify a keyword it operates on, do the operation, and tell us what symbol to use when producing the output. Adder implements it. What we want to do now is write a class that does that same work that CalculateHelper did, but do it in terms of handlers that implement the interface rather than a set of hard-coded operations. So let's go and add another class to our project. We'll call this our dynamic helper. So we have our dynamic helper class, and what it will do is store a list of handlers, right? So we'll do that as an array. So I'll declare an array here of type math processing called handlers. So that'll be the list of handlers that a given instance of dynamic helper has access to. We'll then have the constructor accept an array of handlers and store it inside of our class variable. So whenever we create an instance of this class, we just pass in that array that contains all the handlers we want it to use. And then from there, we'll add a method called process that accepts a string statement to operate on and returns back a string result. Right, so the idea is that what would come in would be something like add 1.0, 2.0. And then what goes out would be the traditional math representation of that showing the result. So the same work we did earlier in CalculateHelper, but again, we're doing it this time in terms of the interface. Now we still have to do some of the basic work. Like one of the things we have to do is split the statement up using the string split method. So when we split it, we'll use the constant that was defined on our math processing interface called separator. And that constant was a space. We're still going to go ahead and split it based on a space. And then, of course, our keyword is the very first part of the statement. So in this case, that might be something like the add keyword. So now what we need to do is loop through the handlers to find the handler that knows how to handle add. So what I'll do is first of all declare a local variable called the handler of type math processing. And then what I want to do now is loop through that array of handlers to try to find a handler that knows how to handle the keyword that was in the statement. So I'll do down here is I'll create a for loop. Let me just scroll down a little bit so we can see everything a little better. So again, we'll have that for loop that will go through the handlers. So inside there, let's add an if statement. We'll say our keyword, we'll use equals ignore case. And what do we want to do? Well, we want to take the current handler that we're looping through, and we'll call its getKeyword method. In other words, is the keyword in this statement match the keyword that this handler knows how to handle? Okay, if it does, we'll take the current handler and assign that to our local variable, the handler, and then we'll just go ahead and break out of the loop. Okay, so when we get out of this for statement now, we know that we have a handler that knows how to handle that particular keyword. Now we still have a little bit of housekeeping to do. We want to get our left values and right values and convert those into a double. So we'll use the same mechanism we used earlier in the course. So I'll declare a local variable called leftVal of type double. I'll then use the double class's parse double method. And I'll do that for part sub 1. So that would be something like our 1.0 value. Right now we'll do the same thing for right val. So now we have both values. So what we can do is have a local variable we'll call result. And then we'll call the handler's do calculation method. And we simply pass in left val and right val. So when this returns, result now has whatever the result of the calculation was. So what we want to do now is build that string output value. Again, that idea of 1.0 plus 2.0 equals 3.0. Now the code to do that is going to be almost exactly the same as the code we used in CalculateHelper. So I'm going to go over here to our CalculateHelper class, scroll down to its toString method. I'm going to grab the code here where it actually builds the output string. So let's copy that. Back to my dynamic helper, paste that in. Now, of course, I've got to make sure my variable names match. So instead of left value, I have left val. Right value is right val. But now the one for the symbol, like the plus sign, well, how am I going to get that? Well, I'll go to the handler, and I'll call its getSymbol method. So I'll get back whatever symbol is appropriate for this handler. Right? So again, if we look at our adder implementation, right, our keyword is add, our symbol is the plus sign, and do calculation does the appropriate arithmetic. It adds them together. So our dynamic helper we have here now is all set to go. So let's go back to our main program now and create our dynamic helper. So we'll create a local variable here of type dynamic helper. We call the variable helper. We get new up dynamic helper. And we're going to pass in a new array of math processing. And what we'll do is we'll just initialize the array in place. And what we do is put in the implementations we have for math processing. Now currently the only one we have is adder. So I'll just new up adder. And so now what we want to do is loop through each of the statements, passing them into our helper. So we'll go through here, we'll declare a string to get our output. And then we simply say helper helper.process, and we pass in our statement. So when that returns, the variable output should have whatever our helper produced. So let's go ahead and write out output. And so with that, we should have all the code in place that we need at this point to handle that one statement that does the add. The key thing here is that our dynamic helper is doing all the work in terms of the math processing interface. So let's go ahead and run our program and see if everything works as we expect. And it does. If I scroll down here, when we add 25.0 and 92.0, we get back 117.0. So everything worked just as we expected it to, but it did it in terms of the interface. So now in the next clip, let's see what it's like to add another handler into our dynamic helper and see that we can get new processing capabilities without making any changes to our dynamic helper.